This is the marking grid for which I will be marking your reports with, and when we do our practice, we're going to mark each other's, or we're going to mark some other reports using this grid to get our head around it. The achieved column is non-negotiable. You have to do every single thing in it to get a merit and an excellence and an achieved, obviously. You have to have a purpose. You have to select variables. There won't just be two columns, there'll be multiple columns, and you have to choose some variables from those columns. You have to use appropriate displays. The guide gives a minimum of 4 graphs plus a table. It's very clear about where you should be importing a graph in that guide that I gave you yesterday. The appropriate model is a by and by, because when you click on the lowness model, it gives you a model. So that's almost, I can almost tick that box now. This quantitative description is describing the long-term trend using a number, quantitative meaning quantity. So you actually have to put a number to the long-term trend, whether it be a negative, being a decline, or a positive number. And you can either talk about it as per quarter, per month, per year, as long as you give a number. You have to fully describe the seasonal pattern. Okay, we've done quite a bit of that. A non-negotiable is to make a forecast. I'm going to talk a little bit more about forecasting in this video. And then you have to draw a conclusion, highlighting the key points from your analysis and answering your initial question or problem. Think PPDAC from year 11, problem, plan, data, analysis, conclusion. So it has to all tie back to itself. Okay. Now, the only difference really between an achieved and a merit is supported with research. Okay, no research, no merit. And the other major difference is really embedding context every time you discuss. The data is clearly introduced, giving background. Okay, so clearly discuss the background or the context. You have to have done, for merit, a discussion around the residuals and how well the model fits the time series. Think about why there's an outlier in a certain year, and this question here for each of your discussions around seasonal and trend. What does it mean? Okay, so really merit is really about embedding the context and answering that question. What does it mean? Make sure, and I've talked about this, round your prediction appropriately. No decimal places, it's a prediction. Discussion about how appropriate for extrapolating, predicting the future. If there's high residuals, like 50 or like 30, 40, 50% of your composition is made up of residuals, very poor reliability for forecasting. Conclusion is quite similar to achieved. Now, this is where it's quite open-ended. There's only 3 boxes to tick for excellence. Research, clear purpose, select a variable, obvious. But here I've given 1, 2, 3, 4, 5 different ideas as a starting point for excellence. But there are multiple different ideas. It's really about you taking the data and thinking. It's called extended abstract. Okay. And I've also posted an exemplar on a student who, I've done this to a certain degree, and I think it's an excellence report, probably a low excellence, but I've sent that to Schoology, so you can have a look at that. And this person has another idea on how to tick this box. So here's a couple of ideas. Discuss the fit of the model, which is kind of, you would be doing that in a merit anyway. The accuracy of the forecast. I'm going to talk about CI in just a minute. What does CI stand for? Stands for confidence interval. Comparison of the series with a related series. So that's where maybe one series isn't enough. So you actually want to do another series, like, because you've got lots of data, choose another series and compare it. That would, in certain data sets, is a no-brainer, depending on the data set you get given. The type of model, that's where you need to do some research on the Holt-Winters prediction. what does hot winters mean? So you need to do a bit of research around that for excellence, possibly. The impact of other relevant variables. So that's what we call lurking variables. So you might find a relationship or a prediction, and there might be another relevant variable to discuss or go and research. Like, for example, population growth and house sales. You might get given data on house sales, for example, but it's quite important to predict what's happening with the population of Auckland, because that may directly influence house sales. And here I've just said any other statistical insight you can think of. So there's lots of opportunity to go deep and really think abstractly with excellence. And then again, it's a well justified conclusion that answers your problem, and you've gone hard and done a really good report, basically. That's what excellence is. So that there now I've put on Schoology. You can have a look at it. And one thing just to show you on the exemplar, this is an exemplar of a low excellent. This student has actually gone to the and done 3 time series graphs. One's Ross River fever, one's dengue fever, and then this is the total of Ross River and dengue fever. So this context was actually about diseases that were cropping up in America, and looking at 2 of them, and they've done a total. So it was almost set up to do that, and it would be a bit of a mistake not to actually do a total or just to look at one of them if you're gunning for excellence. And just something interesting here. This is her talking about her predictions. And what they've done in this section, you can read it, is they've removed the last 3 variables or the last 3 data sets, then got the New Zealand grapher to make a prediction, and then did a percent error. We've done a bit of that in class. I haven't given you the whole set of data. I've said, what do you think your prediction is? These are the actual answers. Let's look at the percentage error and see were the actual predictions relative or reasonable. Most of the time they are, because it's reasonably clever at predicting. Okay, just want to spend 2 minutes talking about predictions. That'll take me to 10 minutes. This context here is male live births. Raw data is in black. The model is in blue. And I would imagine the residuals are quite large here. Why do I imagine that? Because I can see quite big discrepancies between the raw data and the model. That's a big residual right there. The other thing that I knew that the residuals were big is because the width of this confidence interval, right? The red line's the predictions, and this width of confidence interval is growing rapidly. If I look at this forecast chart output, so this is the 4th graph, and this is the one table you need in your report. Minimum and maximum. Now this is what we call, I appreciate we haven't actually talked about confidence intervals because it's actually to do with another topic. Maybe you remember a 95% confidence interval from a level 2 inference. You guys would have done inferences last year if you did level 2. Or a 95% confidence interval, you would say that 95% of the time, or it's 95% likely that the prediction will fall between these 2 numbers. Okay, so this is the actual prediction, but then there's this interval of 95%. Now, if you look in that excellence exemplar, you won't see the words 95%, but you will see the words very likely. And if you recall back, those words very likely mean 95%. Did anyone remember that? Yeah? So check the exemplar for how to do your prediction. I'll just show you another quick one. That was births. Don't click on any of this old stuff, will you? Yeah, don't click old time series, but forecasts, change the variable 1 to the time. Well, that's poor as well, isn't it? That interval is getting wider and wider and wider. Something else I haven't mentioned either is this model I've talked about. This is the lowness model based on the exponentially weighted smoothing technique. Quite complicated, and again, it's a black box. This model is called the Holt-Winters model. Again, based on the exponential smoothing technique, and again, it's a bit of a black box as to what actually the computer does to make this prediction. If for excellence, you want to do a little bit of research and just say add, this is based on the Holt-Winters model, and it's particularly good if the seasonal pattern is regular. Where you have irregular seasonal pattern, the Holt-Winters model is not so strong. Okay, so don't go into too much detail about Holt-Winters, maybe a sentence or two about it. But this is the lowness model, Holt-Winters model for predictions. I have sent out some information via Schoology on Holt-Winters. Have a quick look.